Before forests covered the continents, before insects filled the air, before reptiles roamed freely across dry land, there was a time when Earth's surface was almost empty. Not silent, but exposed. Vast stretches of barren rock and sand, shaped by wind and water, stretched across the continents. There were no trees to break the horizon, no grass to soften them, no shade, no shelter, no protection. Only a harsh, open world under an unforgiving sky. And yet life was already there. It just wasn't where it is today. For hundreds of millions of years, life existed almost entirely in the oceans. Beneath the surface, ecosystems thrived, complex, diverse, and constantly evolving. But the land above remained largely untouched. A frontier. And like all frontiers, it came with challenges. The first problem was simple but devastating. Dryness. Water, the foundation of life, was not guaranteed on land. In the oceans, every cell was surrounded by it. On land, it could disappear in moments. Any organism attempting to survive outside water faced the constant risk of drying out. The second problem was gravity. In water, buoyancy supports the body. Movement is smoother, less demanding. On land, that support vanishes. Bodies must carry their full weight. Structures must become stronger, more rigid. The third problem was exposure. There was no protection from ultraviolet radiation. No thick vegetation to provide shade. Temperatures could swing dramatically between day and night. Conditions were unpredictable. And still, life began to move. The first pioneers were not animals. They were plants. Around 470 million years ago, early plant life began to appear along the edges of water. Simple, low-growing organisms similar to mosses. They stayed close to moisture, clinging to damp surfaces where survival was possible. These early plants didn't have roots as we know them today. They didn't have complex vascular systems. But they had something critical. They had the ability to survive, briefly, on land. And over time, that was enough. Generation after generation, plants adapted. Some developed simple structures to anchor themselves more effectively. Others evolved ways to retain water, preventing rapid dehydration. Slowly, the green spread. Not across the entire land at once, but in patches, thin layers of vegetation hugging riverbanks, coastlines, and regions. But even these small changes had a massive impact. Plants began to alter the environment itself. Their presence helped stabilize soil, reducing erosion. They interacted with rocks, contributing to the formation of early soils. And most importantly, they began to influence the atmosphere, absorbing carbon dioxide and releasing oxygen. The stage was being set. Because where plants go, other life follows. Soon after plants established themselves on land, something else began to appear. Arthropods. Ancient relatives of insects, spiders, and millipedes were among the first animals to make the transition. They were small, often no larger than a few centimeters. But their bodies gave them an advantage. A tough outer shell. This exoskeleton provided protection against drying out. It also offered structural support, helping them move across solid ground. At first, these creatures remained close to water, just like the early plants. Moist environments were still essential. But as plants spread and created more stable conditions, arthropods began to explore further. They crawled across damp soil. They moved between patches of vegetation. They became the first animals to truly walk on land. Their presence marked a turning point. For the first time, ecosystems were forming outside the ocean. These early land environments were still simple, but they were alive. Plants provided structure. Arthropods began interacting with them, feeding, moving, and contributing to the breakdown of organic material. A cycle was beginning. But another major transition was still to come. The move from water to land for vertebrates. Around 360 to 370 million years ago, during the late Devonian period, certain fish began to show unusual adaptations. Some had stronger fins capable of supporting weight. Others had lungs in addition to gills, allowing them to breathe air when oxygen levels in water were low. Scientists believe these adaptations were responses to unstable environments, shallow waters that could dry out or become depleted of oxygen. In such conditions, the ability to survive outside water, even briefly, became an advantage. And so, slowly, these fish began to do something extraordinary. They began to venture onto land. Creatures like Tiktaalik represent this transition, a form that existed between fish and early amphibians. With features suited for both aquatic and terrestrial life, it could navigate shallow and possibly push itself onto land when necessary. This was not a sudden invasion. It was cautious, tentative, step by step. Early amphibians followed, evolving limbs capable of supporting their bodies. They could move across land more effectively, exploring environments that had never been occupied by vertebrates before. But they were not fully free. Water still controlled their lives. Their skin remained sensitive to drying out. Their reproduction depended on water. Eggs had to be laid in moist environments, limiting how far they could travel. Land was accessible, but not yet conquered. And the challenges remained constant. Dryness, exposure, instability. But the world itself was changing. As plants continued to evolve, they began to grow larger. Vascular systems improved, allowing water and nutrients to move through their structures. This made it possible for plants to rise higher, creating the first primitive forests. With height came shade. With density came protection. These early forests transformed the environment once again. They reduced temperature extremes. They increased humidity. They created microhabitats, small areas where conditions were more stable and life could thrive. For animals, this was a breakthrough. The land was becoming more habitable. Arthropods diversified. Some grew larger. Others adapted to different roles within the ecosystem. The variety of life increased. And among vertebrates, a major shift was about to happen. The evolution of the amniotic egg. Unlike amphibian eggs, which required water, these eggs had protective membranes that allowed them to develop on land. This meant that reproduction was no longer tied to environments. It was a turning point. Early reptiles emerged, creatures capable of living entirely on land. They could move further, survive longer, adapt more freely. For the first time, land was not just a place to visit. It was home. But even then, the conquest was not easy. Environments were still unstable. Climate shifts, geological changes, and competition continued to shape life. Some species thrived. Others disappeared. This process of expansion, adaptation, and loss defined the early history of life on land. It was not a single moment. It was a struggle. A long, gradual transformation driven by countless small changes over millions of years. From simple plants clinging to damp, to arthropods crawling across primitive soil, to vertebrates taking their first steps beyond water. Each stage built upon the last. Each challenge forced new solutions. And each solution opened the door to something greater. The world that exists today, filled with forests, animals, and complex ecosystems, is the result of that journey. A journey that began with the first creatures brave enough to leave the water and face a world that was never meant for them. They did not just survive. They changed the planet forever.